Okay, in this video I want to talk about number lines, inequalities, and rounding. All right, so we now know what a natural number is, 0, 1, 2, 3, 4, 5, etc., etc. And we're going to be obviously combining these quantities. We'll have a certain quantity, we'll remove some objects, we'll add some objects, and so we'll obviously be doing puzzles and problems involving them. So I want to give you now some tools, one big tool to help you in your future math classes to help you solve problems. All right. So what people love to do is they love to picture the numbers on a line. Okay. And some people work better with pictures. Their minds just work with pictures. So that's another good reason to learn about the number line. And there's no shame in solving problems by thinking of pictures instead of digits and numbers. All right, if you can get away with it. So let me go ahead now, and what we do is we will typically have the natural numbers equally spaced apart. All right, so we'll pick a position on the couple positions on the number line, and then we'll start writing the natural numbers. All right, and of course this goes on and on, so I'll just put a dot dot dot. Now this is what you might want to use. For example, let's say that you had 3 iPhones and somebody bought you another iPhone. I'm not sure why you'd have so many cell phones, but just bear with me here for a second. So you started out with 3, so that means you're right here on the number line. Okay? Now, if you increase the quantity by 1, all right, you can think of that as moving to the right 1 step, so to the next number. So that means you would end up on this blue dot, right? Okay, so you can see that adding quantities is moving to the right. Later on, we'll see, or you can see right now, that if you remove quantities, that would decrease the quantity that you have. That's like moving to the left. So if I had 3 iPhones, I'm at the red dot position. I remove 2, that's taking 2 steps to the left, so I end up at the green dot. Okay, that's a little introduction to the number line. Now, it doesn't make, we also talk about the distance between numbers. That makes no sense unless you're talking about the number line. All right. If I was to say what's the distance between the numbers 1 and 4, all right, that doesn't mean anything. 1 and 4 are quantities, are digits, right? You can't really talk about a distance. However, if you're talking about the number line, can you see that you can look at it and you can see, look, there's 3 hops, there's 3 steps, okay, between the 1 and the 4. Okay, I have to go, how many steps do I have to do to go from the 1 to the 4? Well, let's see, let me use a yellow highlighter. Well, I'll go from the 1 to the 2, the 2 to the 3, and the 3 to the 4. So that's what people mean when they talk about the distance between 2 numbers. Okay? They also will sometimes talk about the ordering of numbers. All right, they'll say one quantity, one number is bigger than another, or smaller than another number, or equal to a number. Okay? Now, one way to think about that using the number line is if a number is bigger, it is farther to the right on the number line. Okay? So let me put that here. If a number is bigger than another number, it will be farther or more to the right. All right. If a number is smaller than another number, it will be more to the left. All right, and so it's again, we're trying to train you to think of quantities, but also this number line picture. Okay, you can you can use a shorthand notation instead of having to. You see how I had to write out all that text? All right, watch this. 5 is bigger than 3. If you have $5, you have more than $3, right? The way that you can write that in a nice compact way, I'll do it in the upper right, is you say 5 and then you have this little symbol 3. All right? Sometimes people will describe it as, imagine that that symbol is like the mouth of an alligator, and so the alligator wants to eat the biggest amount of food, so that's why it's always going to open its mouth towards the biggest. All right? Let's say I wanted to say that 2 was less than 6, or 6 was greater than 2. All right, although both of those are basically the equivalent. So 6 is bigger than 2. I would say it that way. 2 is less than 6. I'll write it like that. Can you see that when I reverse the positions of the 2 and the 6? Can you see that if we want to call it the alligator's mouth, can you see that the alligator's mouth flipped and that now it pointed to the 6, which was to the right? All right. So these are the symbols you will use. That's called this. Let me change colors here. So this symbol is called the greater than symbol. So we, like for the first example, 5 is greater than 3, and for the 2 and the 6 one, I say 2 is less than 6. So I use that symbol, which is the less than symbol. All right, and those are the basics of inequalities. Now, sometimes you might want to say that a number is either it's bigger or it's equal. All right, now let me show you the equal symbol if you haven't seen that before. So we obviously know that $4 is equal to $4. We know that 4 is equal to 4. That's the symbol for equality. Okay, I'll put it here under my greater than and less than. Okay. So what if you want to say that a number is either bigger, greater than, or it's equal? All right, I'll put that in the upper left in, let's say, green. All right, so what that is we say like 10 is bigger than or equal to 9. Okay, 10 is also bigger than or equal to 10. Now, 10 is not bigger than 10, but it is equal. That's why it gets to pass the test. And then I'll also in the upper right do it in green. You can have less than or equal. So like 8 is less than or equal to 22, and 7 is less than or equal to 14. Those are two other examples. All right, so that's all I want to say about ordering and inequalities. Now let me talk about rounding. So sometimes you will see people ask, well, I want you to give me the number that's a certain quantity of tens that's closest, or a certain quantity of hundreds that's closest to the number that I'm giving you. All right, so let me show you what I mean by that. So let's say that you had $21. Okay, now what are, if you had only groups of 10, what are some quantities that are groups of 10? Well, you could have no groups of 10, that would be 0. You could have one group of 10, that means you would have 10, let's say, goldfish. If you had 0 groups of 10 would be 0. One group of 10, let's say goldfish, one group of 10 goldfish would mean you had 10 goldfish. 2 groups of 10 goldfish, well, two groups of 10 goldfish would mean you had 20, etc., etc. So 10, 20, 30, 40, you get the picture. All right, so if somebody said this, let me type out the wording to make sure that we do it correctly. Okay, so somebody might say round 21 to the nearest 10. All right. Now, when they say that, what they mean is to the nearest of those green numbers in that column right there. All right. So for 21, the nearest number that is only a certain number of quantities of 10, the answer would be 20. See that? All right. Let you try a few now. So let's have you, how about let's say I'll do it on the right, round 39 to the nearest 10. And then after you're done with that, round 20, how about 124 to the nearest 10? Okay? So for the first one, 39 would, the nearest 10, as they say, is 40. So let me write 40. That's the answer. For the one below, 124, to round that one to the nearest 10, we would say 120. All right? Very good. Now, let me give you a few more examples, but before we do that, I'll give you one that might cause some confusion. All right? Round 35 to the nearest 10. Okay? By the way, if I asked you how to interpret rounding on the number line, hopefully you could see what that interpretation would be. So you're simply, when you say round to the nearest 10, you're simply asking which 10, 20, 30, 40, 0, 10, 20, 30, 40, out of all those numbers, which one has the smallest distance to the number I'm thinking of, right? So rounding is about finding the smallest distance to a set of numbers. Okay, to an element in the set of numbers. All right, so now 35, let's round that to the nearest 10. Okay, if you understood what I just said, I hope you see that 35 is the distance of 35 from 30 and 40 is exactly the same, isn't it? So which one do we say do we round it? Do we say the answer is 30 or 40? Okay, remember when I told you about natural numbers and whole numbers and counting numbers, and I said some people include zeros, some people don't? Well, it's a similar situation here. People will, in different situations, they will round a number that ends in 5 differently. Okay? Let me tell you a common procedure and what I will do most of the time in this class. All right? So what I will do and what a lot of people will do is simply round to the biggest number. So if you have a choice between, in this case, 30 and 40, say the biggest one. All right? So this one I would say rounds to 40. Whereas, again, some people out there in the world might say 30 because they like rounding down. Okay? They call it rounding down because they're going to a smaller number. Okay? So let's do a couple more practice problems, and then that'll be it for this video. So round this. Let's see. Let me write these out very nice for you. Okay, round this number to the nearest 100. Round this number to the nearest 1,000. Round this number to the nearest 10,000. All right, and then we'll stop with that. We'll end with those three. Okay, so the first one, round to the nearest 100. So that 234 is closer to 200 than it is to 300. So for that one, the answer is 200. Hopefully you got that correct. On the next one, the nearest 1,000. So that one, the choices, the numbers that you might think might be the answer are 97,000 and 98,000. And I hope you can see that it's closer to 98,000. So I would write that for the answer. However, now let me quickly say that when you enter big numbers in the homework site, you don't want to use commas. All right, commas will cause trouble. All right, so the last one, 65,000 to the nearest 10,000. So the choices there are 60,000 and 70,000. And you can see that we have the same issue with rounding that I was talking about, right? Because of the 5. All right, now this one, the number doesn't end in 5, but because we're trying to round to the nearest 10,000, the 5 is still causing a similar problem. So once again, I'm going to use the convention that I and a lot of people use. So I'm going to say the answer is 70,000. All right, and that's all I have.